are back today, and we got some excellent questions from our discussion yesterday in lab. And one of those questions, everyone's just addicted to Mathematica now, whether people like it or not. And so instead of using the Z table, which we see here on our lecture notes, to solve basically some of these problems with our distributions, seeing how much data falls within 90% or 95% or 99% or 50% of our data, people wanted to instead use using the Z table, which is, I do agree, is arduous. People wanted to solve this in Mathematica, so I'll be happy to show you how to do so. So in our lecture notes, we saw that with the change in variable, we could change our probability density function from a function of f of x. So we want to go from a function of f of x to a function of f of z. So we introduced this new variable z, which accounts for basically x. As you kind of see here, you rewrite our expression, and this is what it becomes. So when we are using our z function here, and we're using kind of these kind of parameters, if we want to solve and basically use this function to get our probabilities, we have to make one more little step that's kind of a hidden one in the notes. So it's shown and explained well in Mathematica. So when we convert and do this kind of z function, we do this basically assuming that mu is equal to 0 and sigma squared is equal to 1 in the most general normal distribution. So that's kind of how that z table you see here is generated, right? The z table that we are working with goes from values of z from 0 to -1. So it's effectively the same thing as setting this mu equal to 0 and our sigma squared equal to 1. And the only other thing that we need to kind of mention is that when we do the integral of our function p sub x, d sub x, we are going to again change it to p sub z, d sub z. D sub z is just d sub x divided by sigma. So that is going to give us, basically, we're going to resolve and obtain that same function again. So that's the basics of what we're going to be doing in order to kind of solve these functions in Mathematica. So that's enough talking for me, although you know I'm always going to be talking a little bit more. So let's actually do an example and kind of confirm some of our answers that we kind of talked about previously in the last video. So first things first, let's pull up our Mathematica and get started. So I pull up Mathematica. I want to do my f of z function. It's just going to be 1 divided by 2 times pi. Oops. 2 times pi. And then exponential minus z squared. All that. And people, you probably don't need parentheses, but I'm a little bit paranoid. And this has to be a square root. Leave. So that's our f of z function. So if I integrate, what is the integral of f of z from z equals minus infinity to infinity? Everyone's saying it in unison online, virtually, I know. I believe in you all. 1. That's a good check. What about from 0 to infinity? Half. That's another good check. Matches our z table value. What about from minus, how about from minus infinity to 0? Make sure we're symmetric. Otherwise, we've broken the laws of statistics. Excellent. So we're good to go on here. So if I look and if I want to integrate, I know from my z table value that if I want to calculate a 90% confidence interval or 95% confidence interval, that's 0.475. That is z value of 1.96. So if I integrate, sorry, let me go back here. If I integrate f of z from minus 1.96 to 1.96, I get 95% approximately. Again, I could actually solve, and you could kind of look at this for the exact number, because it's not exactly 1.96. F of z from minus x to x. And I'm going to integrate, I want this to be 0.95. Solve for x. And you can kind of see the exact numeric answer there. Pretty much 1.96. If I want 90% confidence interval, I get this z value. If I want 50%, I got this. If I want 75%, I have this. And again, I could use this to solve for some of the problems that we worked with previously in the last video. So if I'm looking for, I have a mu of 39, I have a sigma of 4 pascals. Let me pull up my Mathematica notebook so we can work with this. Here we go. And I'm trying to find how many measurements fall between 35 and 45 pascals. Well, I know that my, I think I erased it. So my z-value of 35 minus 39 divided by 4, that's my z, x minus mu over sigma. That equals minus 1. What about our other value, 45? That's 3/2. So if I want to integrate my function here between those two z values from minus 1 to 1.5, let's see what I get. 0.774, and let's see if we still have that. Yep, pretty much right here. So just like we saw previously. So that's a quick way where you could use Mathematica to basically solve for some of these functions, these probabilities, how many data points are going to fall between certain bounds, calculating those bounds. So I'm really happy everyone's really taking on to Mathematica. So go ahead and use this to solve for your exams and problem sets. And yeah, go at it. Proud of you all. All right, I'll see you in class in a little bit. Thanks. Bye.